All right. Well, hey everybody, good morning. Thank you for taking a few moments and being patient with us as we figured out some AV issues. I'm not promising that my demos are actually going to work, but at least we're going to have slides, so it's a good start. My name is Brandon Satrom, and I want to talk to you today about JavaScript and IoT specifically, because there's never been a better time to be a JavaScript developer. You all know that. Hopefully that's why you're here. That's true for the web, it's true for mobile, and it's true, believe it or not, in the world of the Internet of Things as well. And today I'm going to share a few ways that JavaScript powers the next generation of IoT systems. But first, I want to start with a story. It's a story of the Internet of Things, all the way back over 100 years ago, and even the Internet itself. In 1880, Thomas Edison was granted a patent for the very first electric light bulb, which marked a beginning of a new era in human history, that of power. For the first time, we could harness power to control our homes, to control light in our homes, our cities, and our cities around us. And some luminaries, like Nikola Tesla, like the great Nikola Tesla, had a bigger vision. More than just powering and heating our homes and our cities, Tesla had an idea that electricity itself would define the next era of human history. In fact, Tesla imagined a future where electricity would allow us to become unchained from traditional systems and from traditional ways of living and modes of operating, and power our devices on the go. And while Tesla's vision of wireless transfer of electricity hasn't quite yet become a reality in the way he envisioned, he wasn't wrong about being able to carry devices in our pockets back in 1926. And it's quite amazing to think that not only was Tesla right about mobility, but he predicted the huge brain that we refer to as the Internet of Things today. And what's more, he described a future that is today's present. We are living in the future that people like Nikola Tesla predicted and envisioned as the ideal future for humanity. And of course, much of our attention in computing in the last 60 to 70 years was focused on computing in general. From the 60s to the early 2000s, the focus of technology was about making the personal computer a reality and ubiquitous. Then on the internet, and then finally on mobile. And as soon as connected computing via mobile became more of a reality, our focus shifted to this idea of every single thing around us being connected. Connectivity moving out into the world and into this idea of things powering our homes, our farms, our cities, and more. And of course, with this level of prognostication came ideas of billions of devices and trillions of dollars in opportunity. But the IoT's position today, according to most analysts, still seems to be well off the promise. It's actually kind of crazy to think that according to GARTNER and others, where the IoT stands in the minds of many today actually will probably get worse over the next couple of years before it gets any better. We think that we're going to have a future of tomorrow where we move into the slope of enlightenment, as GARTNER calls it, and the IoT becomes this wonderful idealized future where we have connected devices everywhere, and we're all very happy about that. That's not the world that we live in today. I think most of us have become very disillusioned with the idea of the IoT. Many people don't understand why in the world we even put Wi-Fi chips in toasters and in our fridges and microwaves and everything that you could possibly imagine. And I think part of where we are, and even though this is expected, every technology innovation follows a very similar trend, even though this is where we are, it's on us to get from this point today to the future, to this idea of the IoT of tomorrow. And I believe really strongly that to exit the trough, to move very quickly to that place where the Internet of Things is used and fulfills the promise that we think that it has, is we have to focus on solving real problems. I want to share a couple of examples of those today because those will factor in to what I want to share with you about how JavaScript factors into this story as well, and to share you 3 examples of companies out there that are solving really interesting problems with connectivity in a way that wasn't possible 5, 10, and 20 years ago. One of these is a product called the Smart Fin, which is a swap-in replacement for a typical surfboard fin. And this is a green initiative from the Scripps Institute of Oceanography, the Surfrider Foundation, and Lost Bird 9. And the SmartFin itself tracks your surfboard's location, water temperature, the motion of each breaking wave, pH levels of the water, and it streams all that data using a built-in cellular device where the data is collected to provide a picture of the environmental conditions of water near the coastline. Now, why is this important? Scientists have ways of deploying buoys and other devices to measure those things in oceans today. But the one area where they can't do that is where the water is very choppy near the shore. It turns out that's where surfers love to be. So this is a very easy solution where a surfer, an individual, can make an impact and provide a better picture of our oceans, an increasingly scarce and at-risk resource. Another example is called the BuzzBox from OSB Hives. And the BuzzBox is actually a Wi-Fi connected device that helps monitor the health and safety of beehives. All of the data that they collect is processed in the cloud, and they analyze the sounds that they're hearing from those beehives to determine the health of the hive, whether the queen is sick or has died or has left the hive altogether. And they can do that by processing the information on the sounds that they're hearing from the devices connected to the hives. And in this case, connectivity enables that OSB Hives team to analyze the data, to apply machine learning algorithms, and to obtain insights not possible today on constrained embedded devices, which gives beekeepers control, the ability to control and manage their hives, which is a very, very important thing. And then finally, EnviroFit. This is probably one of my favorite stories of modern connectivity. And in some of the poorest parts of the world, a lot of cooking happens over open fires and much of it indoors. This is a health risk for the people living, and it's also potentially damaging to the environment. So EnviroFit creates high-performance, environmentally friendly cook stoves that are tailored to the cultural cooking and cooking habits of customers in developing markets. Now they work with a lot of markets in Central and South America to actually tailor these to those cultures, to the styles of cooking in those countries and those environments. And then they track how those stoves are actually being used so that the governments that are sponsoring their work can have an idea of whether the stoves are being used or how their system needs to change in order to better suit those populations. And this is another case where, again, connectivity is helping solve problems. But in all three of these examples I shared, connectivity helps the company solve a problem in a way that would have been much harder just a few years ago. These forms of connectivity, however, create interesting challenges for traditional developers and for people who have built embedded systems previously, because the kind of embedded systems that we used to build, the kind of embedded systems that a hardware engineer is familiar with, can be a complicated system, and perhaps it has some sort of sophisticated device that controls a machine on a shop floor, and perhaps there's a monitoring system, but all of those things are localized to the environment. They're localized to the shop floor or to the factory. If a system breaks, you replace it. That's all there is to it. Everything is local to that environment. But connectivity actually helps us do new and interesting things with embedded systems. These types of systems themselves are becoming rare because of the power of the cloud. And this is not just about putting a Wi-Fi or a cellular chip in something because we can, but about enabling connectivity at a distance, enabling remote monitoring of systems on a shop floor from 100 yards or 100 miles or 1,000 miles away. But it's also building systems that enable us to control systems remotely so that when a system goes on the fritz, we don't have to be on site in order to fix it. And then finally, it's about enabling the kind of insights that only the cloud can provide so that we can anticipate when systems have problems and potentially fix issues before they happen. So what's ultimately happening is that Internet of Things solutions are about much more than embedded hardware and software. The types of systems that we built 30 years ago were very self-contained. The types of systems we build today, connectivity is baked in. And it's not just because we can, but because of the types of problems that connectivity enables us to solve. And while most hardware engineers are perfectly comfortable with embedded systems that they love, can work very, very seamlessly in this sort of environment, everything on the right side of this slide are things that are mostly new to a typical hardware engineer. They're not familiar with web, mobile, and cloud type solutions. These are the kinds of systems that are very much in demand for the IoT. We have a world of hardware engineers that can build embedded systems, but what we don't have in the world of IoT is developers that can extend that intelligence into the cloud, into mobile, and into the web. And JavaScript, of course, is the nearly ubiquitous language that ties all three of those types of apps together and can better enable the Internet of Things. And that's where developers such as yourselves come in. Because as JavaScript-savvy individuals, there's never been a better time to dip your toe into the Internet of Things and to help solve real problems. I'm going to look at these three different types of apps today and share with you a couple of different examples. But really, if you take nothing else today, take away this, that I believe that IoT builders are actually the real full-stack developers. So if you want to call yourself a full-stack developer, come in to the IoT waters. They're fine, I promise you. It's a lot of fun. So we're going to look at examples of each of these three types of apps. I'm going to start with IoT web apps. And there are a lot of companies that build hardware, that build software and platforms in this space that are really interesting. I'm going to share my bias. Full disclosure, I work for an IoT hardware and platform company called Particle. And we provide solutions in all of these spaces. So of course, that's what I'm going to talk about. But I highly encourage you, as you're looking at this space, to check a lot of these things out for yourself. There are definitely other great tools and services out there. So first, IoT web apps. And why are these important? Why do we even care about building web apps in the context of the Internet of Things? And the answer is because they provide data aggregation and visualization. The web is a natural place to bring the sensor data that we're collecting together, to illustrate trends over time, and to provide customers with insight into what's actually happening in their systems. One of my favorite examples of this is a company that I actually got to meet in Oslo, Norway earlier this year, a company called Roast. Roast makes a sample roaster for larger industrial coffee makers. This is not a consumer device, even though it has a very nice industrial design. I asked them if I could buy one, and they said, no, I cannot. I think they figured I couldn't afford it. But this is for professional coffee roasters. They buy these machines, and when they buy samples, when they buy large batches of green coffee beans, they use this roaster to roast a very small sample that they then test to see if the entire batch is good or bad. And they use a web dashboard to visualize everything that's going on in the process as that roasting is happening over time, over multiple batches, et cetera. They're collecting all of that sample data and visualizing it for the customer in real time. Now, most of you all are familiar with this. Most of you are very well versed in building web applications, so this is not a hard part. The second part of this question of how you build an IoT web application, that's easy. You do what you do today. But the one thing that's unique is figuring out how you actually get data from those devices. Getting data from the source is the key piece here. And in a lot of embedded systems, there's two or three common ways to do that. One of the most common ways is to implement MQTT yourself or to do TCP pub sub yourself on a device. I'll share another example from my company, from Particle, where we actually implement pub sub in the embedded device OS that you can use yourself. But ideally, this is the key point. You take data from the device, you actually get it somewhere on a server, and then from that point, go nuts, build your web application using whatever language or framework that you prefer. I'm not going to get involved in any of those kinds of arguments. Do what you like. But the important thing to note here is that when you're looking at actually getting sensor data from devices, you want to use a system that makes it very easy to ingest sensor data and then get that to its ultimate destination. And the way that Particle does that is we provide 4 device primitives, we call them, inside of our embedded device OS. Those are Particle variables, which can connect to sensor data, connect to global variables inside your code that represent sensor readings, temperature, humidity, etc. We have functions that allow you to actually call functionality that's exposed to the device to turn on an actuator, to read a sensor value, something along those lines, and then publish and subscribe. And publish and subscribe is the way that devices can communicate with one another. So you can actually send messages between individual connected devices. And publish and subscribe is also the way that you can actually pull device data, sensor data into the cloud. When you do a publish on any piece of Particle hardware, that information actually goes to the Particle device cloud that we host, that we provide, that ingests all that data for you, and then you go and do something with it. Now, the key here is that server, right? Is having a place where you can actually put your data, whether you're rolling it yourself, or whether you're using another vendor's product, you need to have an API of some kind, some place for your data to be, and then a way to actually get at that. Because a good API really is the foundation for being able to do extensible IoT development. And this is an important thing that I want to note here, because again, as developers, as professional developers, you all are used to using high quality APIs or evaluating products based on the quality of their API. And working with an IoT system is no different. You want to make sure that your ability to get at that data and use it for your own applications is easy and is turnkey. Because after all, and I'm not a huge fan of quoting talks that I gave 5 years ago, but I will quote myself in this case. API design is developer UX. And so when you're looking at a system, whether it's an IoT system, a JavaScript system, a third-party system, make sure that the API actually works for you. Now, of course, in a bit of homerism here, I'm setting myself up well, because I do believe that Particle has a very robust API. When you get your data into the device cloud, it's very easy to get it out. You can actually get access to publish and subscribe messages. You can get access to anything that you've built inside the system. And because we have a very robust API, it's very easy for us to then provide a JavaScript library on top of that. So this is sort of the punchline to why I'm talking about APIs in the first place. When you have a good API, you can build systems and SDKs and tools around that make it really easy for you to leverage those underlying systems. And so Particle has a JavaScript API that makes it very easy to understand the state of your individual devices, to call those variables and functions that I mentioned earlier, and to perform publish and subscribe messages between devices as well. So, I am going to show you very briefly what I mean by that. And pull open, see if I don't have all my demos open here. Y'all bear with me for a second, I had to do a restart. With that, and let me actually run that. I'm going to run this one too. So that one's going to take longer. Okay. So I have a very easy, simple website that I've built. This is with Vue.js. Oh, look, Burke, that's you. So this is a system that I built with Vue, and I'm using the Particle JavaScript API along this. Now, what this web dashboard is showing me is it's sort of it's an interface on this little interactive conference badge that I built that has a piece of Particle hardware on here. It has a couple of buttons. It has a temperature and humidity sensor and a screen and a few other fancy things like that. So I'm reading the current temperature and humidity. I'm also pulling in from the saved memory on the device the name of the person that is wearing the badge or should be wearing the badge. I don't know why you won't come wear the badge, Burke. I don't understand. No, you want to you want to be in my demo? Come wear the badge. Okay, yeah, all right. Burke is going to come put the badge on. It's heavy. It's got a big old battery on it. So, and then a couple of events that I can fire. I'm not going to mess with those right now. But the way that the app actually works is as any typical, simple JavaScript web app, thank you. I have a couple of pieces of information that are bound to my UI, click events, etc., for things like updating the where name, etc. But the important piece of this is actually the Particle JavaScript API. It's an npm installable package. I've pulled it in. I've passed in. You can take a picture of my token if you want. I promise that I'm going to invalidate it as soon as this talk is over. Maybe. Maybe I won't. Maybe you can mess with all my devices. And then the ID, the device ID of this individual badge. And from this point, the real secret sauce is actually doing things like getting device information. So getting a variable is as simple as just calling particle.getVariable, getting the first name of the where, and then passing that in to my local state in the Vue application as well. Same thing with Twitter handle. And then when it comes to actually updating, I have a function called update first name that shows up, and I can actually, so Burke here, we will have this scroll your name on here real quick. So y'all can maybe kind of see that a little bit, but there's an update first name function in here that anytime I call that, that'll actually change that information. So I'm going to change this to be Brandon Satram, and I'm going to click update. And that will actually, if it works, it should actually change. Yeah, so it'll change. Now it's my name. And then, even though Burke's Twitter handle is much better than mine, I'll change that to mine as well, and it changes it on the top of the screen. Now, all of this, this is an embedded piece of hardware that has a Wi-Fi chip inside of it. It is part of a mesh network with other devices as well. But the API, the JavaScript API, is what has allowed me to very easily make changes to that device to actually read sensor information from here. I can tell you it's 76 degrees in the room with 29% humidity. That's pretty nice. That's a pretty good deal. So you're a little sweaty? Okay, all right. It's the lights, the bright lights. But thank you, Burke. You'll give him a round of applause. Appreciate it. Thank you for being my demo monkey. You're awesome. Again, it's the JavaScript API that makes all of this a lot easier. I've done embedded development for many years, started with Arduino several years ago, back in the days where buying an Arduino was less expensive than buying the Wi-Fi or the Ethernet shield that you put on top of the Arduino itself. We've come a long way when it comes to building embedded hardware that is inexpensive. But just having a Wi-Fi chip or a cellular radio is not the important piece here. The important piece is having a simple API that as a developer you can use to build systems that extend those embedded devices and actually do something useful. So that's a brief example of what I mean by building web applications. Now, let's talk a little bit about IoT mobile apps, and things get a whole lot more interesting here. Why do we care about IoT mobile apps? Visualization is important in IoT mobile apps, but control is also important. The reason why we build these kinds of apps is because they are portable and ubiquitous, because they fit in our pocket, because we can use them on a shop floor, in our homes, on the go, on a farm. They work in many different cases. One example of a really interesting kind of IoT mobile app is an app called Blink, B-L-Y-N-K. Now, Blink is an interesting sample here because Blink is a IoT app builder app in many ways. The way that this app actually works is you install their iOS or Android app, and then you connect it to your hardware yourself. So you choose your embedded device. You assign the pins that you want to work with on the device, the digital and analog pins. You say whether or not you want the UI on the app to be a push or a switch, what you want it to do when you click it, and then you write your actually embedded firmware separately. But then what you get out the other end is a UI that this is sort of your purpose-built IoT app. You didn't have to build the mobile app yourself. You installed the Blink app. You connect it to your Arduino or your Particle device or your ESP32, and you're off to the races. That's all there is to it. And that's an interesting sort of model, but it's really only one of three types of IoT mobile apps that you would build. The native apps are, of course, the first example. Building something fully native that connects to an embedded system is one option, using a generic controller app, and then, of course, building a cross-platform app using React Native or NATIVESCRIPT or another solution like that is another great tool as well. Now, a lot of IoT platform vendors will provide SDKs for doing full-on mobile development, and Particle is no different. We have SDKs for iOS, Android, and Windows. We have our SDKs support both Objective-C and Swift. But the reason that this is interesting in the context of JavaScript is because we have these SDKs that are fully mobile, we can play well with NATIVESCRIPT. So our good friend Eddie Verbruggen actually created and has released 2 versions of a NATIVESCRIPT Particle plugin. So if you're building NATIVESCRIPT apps, we have the same sort of fluent interface for working with Particle devices and ultimately our device cloud and our underlying APIs. And so you can build cross-platform iOS and Android apps using JavaScript, using NATIVESCRIPT and Particle, and this all works out pretty nicely. So I'm going to share a demo of this now. Go back to mirroring. All right. Now, so I'm a little partial to Vue. It's really funny because I'm realizing, like, Bert gave a talk on Vue a year ago, and I think after the talk I told you, yeah, like, man, it sounds interesting, but I don't think I can ever switch off of React. And in the last year, I've done 80% of my development in Vue, so I give you credit for that, totally, Bert. I don't know if you want it or not, but I refer to myself now as a recovering React developer. I really love Vue. It's been a lot of fun to work with it, and working with the Vue NATIVESCRIPT framework has been fun as well. So what I have built here in my, it actually works, is a little bit of a mobile app that does a couple of different things for me. If these demos actually work, I got one demo that works, so the day is not a failure regardless of what else happens with these other demos. But I have a couple of sliders here that represent red, green, and blue values on my little Christmas-themed NeoPixel light strip here. When I click the Start Flicker button, what should happen is it's actually going to flicker a little, I guess, holiday-y white flickering animation. And what I can do is actually change these sliders to manipulate the red, green, and blue values to change the way that the light strip actually works. And any time that I change one of those sliders, that's actually it's actually firing messages to my device that tells it to update its value. The way that this actually works, similar, again, I've installed the NATIVESCRIPT Particle SDK. I'm importing that into my application. I have device IDs that represent these individual devices. The important piece here is I log myself into the Particle API, and again, you can write down my password if you saw it come by very briefly, but I will change it after this talk. I will list my devices and then call individual functions. So when I slide any one of those sliders, I'm actually calling this update RGB function, which gets a reference to my NeoPixel device right here, and then calls that function with the endpoint that I provide. And the endpoints are set red, set green, and set blue, and that as those change, that just works all very seamlessly. It calls those functions and then logs the result. The same thing happens when I try to turn on any one of these demos. So my Santa demo is down for the count, but the reindeer over there may work when I click the button, and it may just fall completely off. Hey, that actually worked. Look at him galloping so jollily. That's totally not a design flaw. I click it again, and it stops. I'm so excited these demos are actually working right now. And so in any of these, so again, same thing. I've built a mobile app. It's interfacing with the Device Cloud API under the covers. And it's really easy for me to build something foolish in this case. That's fine. You can call it foolish. I wouldn't be offended. But to build something that actually works with works with these embedded devices. All right. So finally, the fun part, the cloud. Why do we care about the cloud in the context of the IoT? Eddie, I totally just plugged your plugin. You missed it. It's okay. This is the guy that built the NATIVESCRIPT particle plugin, and it's awesome. So thank you, Eddie. It worked. They're clapping because the demos worked, because your plugin actually works. Yeah. So IoT cloud apps, why do we care about these? They do give us insight as well, and they give us control, but we care because the cloud has nearly infinite computational power, and this can't be underestimated in the context of the IoT. All of these systems here are very constrained devices. They can do a lot more than similar devices 5 years ago, but they can't do as much as the computer on your desk, and they can't do as much as a rack of computers buried under the ocean or whatever cloud providers are doing with their hardware these days. They can't provide that same level of insight and power, and so being able to leverage the cloud in the context of IoT actually gives us actionable data. It gives us the kind of intelligence we need to solve real problems, to fix problems before they happen, to replace machines, and things like that. Now, one example of a cloud app that I really love, it's a cloud app, web app that I love in this case, is actually Suze Hinton's ELECTRICIO dashboard. If you haven't used this yet, I highly recommend checking it out. If you're doing anything with the Azure IoT Hub, this plugs right in. And so you can actually mess with, Particle actually has a built-in integration with Azure IoT Hub, so you can take sensor data from your Particle boards, you can actually put them in Azure IoT Hub and use ELECTRICIO to create cool visualizations. So I highly recommend checking that out. In the context of the cloud, there's really 3 different kinds of IoT web or IoT apps that you would consider, that you would think about. One is apps, your source for backhaul, where you're actually storing your data, whether it's on premises or whether it's with a provider like Azure, with AWS or Google Cloud Platform, where you're actually going to put that data when you get it out. Another emerging piece that I'll show a little bit that is kind of interesting is cloud workflow. And cloud workflow is where you're actually pulling, it's sort of an intermediary step between backhaul and what you're doing with your embedded systems, where you can actually add some intelligence in a really easy way. And then finally, cloud processing. This is where the really exciting stuff like machine learning, Watson, these are the examples of where you're actually applying intelligence and insight at scale to do interesting things. But in the context of JavaScript, and why you would care about these types of apps as a JavaScript developer, and of course a lot of these cloud systems, whether it's Azure Functions or Lambda, give you the ability to create systems that use JavaScript fundamentally. Whether you're writing an Azure function or a Lambda function, you're using JavaScript is an option, so it's a great example in this case. But I wanted to actually talk about Node-RED and specifically the Particle IoT rules engine, because the workflow side of this I think is going to become really interesting in the future as more companies, as more organizations adopt IoT systems and need help building intelligence without sinking a ton of money into building those systems. And so the Particle IoT rules engine is a drag and drop IoT application builder. It's built on top of Node-RED and with the help of the IBM team. And JavaScript is the language that you use in all of your flows for adding intelligence, actually adding functions to individual nodes in the system. And the Particle Device Cloud uses JSON to pass data around. So you're ultimately working with languages and in areas you're familiar with. And the whole idea with the rules engine, or even if you roll Node-RED on your own, is that these are an intermediary to working with other clouds. So there's still built-in integrations to go to Azure or Google or to Watson or to AWS. It's an intermediary. It allows you to do interesting things like take action without throwing up a full-scale system. So let me show you what I mean by that. We're going to do a quick demo. I have the Particle IoT rules engine. Let me go back to mirroring. Here we go. So this is a view of the IoT rules engine, and everything that comes in here, the important pieces as it relates to Particle and embedded data is that I have the ability to actually subscribe to messages that come from devices, to publish messages to devices, and also to interact with functions and variables. Just like anything else, just like my web app, just like my mobile app, I have those same APIs available to me. So one of the things that I can show you, I haven't shown this off yet, but Particle actually provides a console with a view into all of your devices. And one device in particular, again, my badge here, is actually publishing sensor data every 2 minutes. So I'm going to go in here so I can trigger it myself. But the console actually provides you with the ability to execute functions and fire events and publish and subscribe as well. So as you're prototyping and working with these, the same things that I showed you in the web app that we did with the badge that Burke was wearing, I can do inside of the console as well. And I can also call check the temperature. And when I do that, it actually it calls my event sensors and fires an event with a temperature and humidity payload. This will show up in my event list as well, and this is what I'm listening for. So I have a node here. If you've never anybody seen Node-RED before? We worked with Node-RED, a few folks. So Node-RED has a few concepts here that are critical. One is this entire palette or surface here is called the flow, and these individual boxes, as you could probably guess, are called nodes. And each individual node does something. It ingests a piece of data, it transforms that data, et cetera. In this case, I am reading from my environmental sensors. I'm converting that to a JSON object, and then I'm debugging it out. Let me change this to just my current flow. Somebody else has errors in theirs, not me. So I'm just writing out my payload every time that comes in. But I'm doing a couple of interesting things with this. Again, as a JavaScript developer, someone that's working with a company that might be new to this space, doesn't want to pour a lot of money into it, you can create easy dashboards using a rules engine or using Node-RED. And so I actually have a couple of dashboard nodes here that I can use to show a gauge for my temperature and a gauge for the humidity. And then also to convert do a little bit of processing on this payload, and then a temperature and humidity bar graph as well. And what that ends up looking like is, as you would expect, a simple temperature and humidity graph, and then gauges for each of those values. And I built this all with the rules engine with Node-RED that gives me those very simple charts and graphs without having to build a full-on application. Now, Another piece of this that's interesting is you can actually work with external services as well. So a lot of the work that we do is not just about reading sensor data, not just about writing out charts and graphs and dashboards, but also integrating with other systems as well. And so I have a node here. This is actually an HTTP request node. And what I'm doing is every 5 minutes, I'm firing off an event that goes to the Open Weather Map forecast, and it pulls the latest forecast for Sofia. And then when it pulls that forecast in, it converts it to JSON, and it does a couple of things with it. Now, this has been disabled, so I'm going to reconnect this node and then redeploy it so that you can see what's actually happening here. And you'll see that the first thing that happens when I come in is I can't zoom that part of the screen. There's a payload object over here that actually has the weather information that I need. I'm converting that to JSON, or JSON. And then I'm doing a couple of things with it. One thing is I'm actually using some templating syntax. So simple mustache templating syntax is available in Node-RED in the rules engine as well. And so I'm basically just writing a div out to my dashboard that shows the current weather and humidity and the outlook. And so you probably saw that on here as well. Currently, misty in Sofia, outside temp is 41, and humidity is 86%. It's cold, y'all. That's the way. I should have just said it's cold. That's what you say. It's cold, y'all. That's how I would describe it. Now, that's interesting, but where's the real JavaScript? Well, Node-RED also provides function nodes, and function nodes can actually allow you to do very interesting things. You can parse data that comes in from payloads, make decisions, fork the flow off based on different things that you want to do. All of that's possible in there. What I'm doing here is I'm passing in. Let me do something really quick. Turn that off. See if this will actually work. Okay. I'm going to say by default it's hot. If the temperature is less than 50, I'm going to say that it's cold. And if the temperature is between 50 and 80, I'll say that it's nice. And then ultimately what I'm doing is I'm publishing a temperature event, and any of my devices can be listening for this. So in this case, this device is actually listening for that event, for that temperature event, and it will set the light strip based on the value that I pass in. So in this case, I'm saying if it's under, right now I'm saying it's cold. So let me go ahead and fire this again. Hey, all the demos can't work. It's okay. But what's ultimately happening on the other side in my code is on my firmware, I'm checking that string that's coming in, and I'm saying if it's cold, set the lights to blue. If it's nice, set them to green. Otherwise, that works. Okay, so it did work the second time around. So it set the string as cold. That's definitely the case. So that worked very well. So the firmware is looking, if it sees cold, blue, green is nice, and then red if it's hot, which is how it is in Texas, like all the time. So this light strip is red except for 3 weeks in January. And that's it. So, and again, Node-RED gives you the ability to build applications. I mean, the whole point of using this is it gives you the ability to build apps without investing a ton, to actually help embedded developers build something interesting. And I mean, that's the whole reason why I came here today, why I wanted to talk to you and share this concept of using JavaScript for IoT systems, because we have an opportunity as developers, as JavaScript developers, as front-end developers. That's how I've spent most of my career. I now work for a hardware company because a lot of the opportunity around building embedded systems falls on us, falls on the front end, the mobile, the web, the full stack developers that actually are going to build the kinds of systems of the future. And as I close, I want to share very briefly a word about real IoT, because I stood up here today and I talked about IoT will really cross the chasm, will move out of the trough when we focus on solving real problems. And then you saw me go and share silly Christmas-themed demos. And there's a reason for that. Of course, obviously, it's easier for me to pull these little demos in than to haul a big industrial machine into this theater and show you a demo of it. But the important thing here is that we're still solving real problems when we explore prototyping through play. This is a very important part of the toolkit for the IoT developer. Every one of these demos that I shared with you today may have had a funny facade on the front of it, but underneath each one of those demos was a real motor, or a real actuator, or a servo, or a light strip, or an LED, or a display. And every one of these things plays into real industrial systems that we use for solving real legitimate problems. So I encourage you all, as you're exploring this space, as you dip your toe into becoming a fuller stack developer, that you would think about these opportunities to solve real problems and explore that with play. Thank you all very much.